Hello again, everyone. I'm Ian McLaughlin, a PhD in neuroscience. I just finished my PhD, which is why it's still kind of strange to say. So I have one pretty cool study for you today. It's about babies because when you have a baby, it's basically all you can think about, particularly when you're a neuroscientist watching this nascent nervous system basically negotiate with its external world. So let's just get started. One of the most interesting parts of having a baby is spending time playing with them. I'm sure that's not particularly surprising, but it's engaging beyond just like the fascination of watching a person that's approximately half yourself belt out a da da, or exploring how loudly they can holler, which is my baby's new hobby. Of course, as somebody who views the world through the lens of neuroscience, I'm kind of subconsciously almost trying to figure out what's going on in her mind during each interaction we have. And, we live in a pretty small apartment in Philadelphia, and we've art and books and whiteboards and furniture. And of course, a bunch of her toys now all over the place. And so basically, wherever you look, there's a thing that's vying for your attention. When I pick her up, I always wonder what it is exactly that determines how she allocates her attention. Why it is that she looks at one book or toy over another. And so, she's also at this amusing stage where she points everywhere at everything and a little bit more awkwardly at everyone. And so, fortunately, most people are lovely and just sort of give her a smile, but it can be a little bit awkward when your daughter's just like relentlessly pointing at a single random person in the airport who's like clearly not a baby person. Anyways, so one of our daily pleasures is playing with the baby. And so thanks to the generosity of a bunch of people, she has like basically a chest full of toys now, all different kinds. But at least at the moment, she's in this phase where all she wants to do is read books. Over and over and over, the same book, different books, a new book in the middle of an ongoing book. And as much as I'd like to see myself in her already, like in her personality, I became, a big sci-fi nerd in middle school, and I've always had like a modest collection of books since then. I think it's really less about the stories in the books, and more about it being sort of like a venue for her to have more meaningful interactions with her mom and me. So, instead of just like talking to her, trying to teach her to say various sounds or words, or like nebulously playing with toys along with her, I think she can sort of understand what's going on as we move through the story. She turns the page, there's a new picture of characters and simple sets of words. And, and I'm sure, by the way, she's like pretty close to memorizing those words at this point. But a kind of similar thing happens when we play music for her. And so, like she'll make eye contact and sort of boogie in this like side-to-side way, which is very cute. And I can sometimes even get her to like vocalize a little bit, almost like she's, trying to sing. Anyway, so there are definitely moments that feel like particularly special. They're like kind of elevated moments of clarity or communication that sort of make you want to laugh and cry at the same time. It's sort of like knowing someone for a whole year. My daughter's just a bit over a year old. And all of a sudden having like a truly meaningful moment with this person. You kind of see a more complete person poking out of, their former obscurity. And so a study was published by a group at Princeton University over there in New Jersey that might shed some light on what's going on neurobiologically in those moments. And so they opened their paper by highlighting the crucial learning that occurs in the first few years of life, developing what they call common ground with other people. And so this involves learning to engage with social environments using a range of behaviors like, eye gaze, facial expression, and speech. And so they highlight that past studies have suggested that when adults experience moments of shared understanding, similar neural responses can be measured in the adults, specifically when inputs are interpreted in a similar way. And so in this case, in this study that they're referencing, they're referring to basically exposing people to a real life story that was spoken in either Russian or in English, which are fairly different languages. And it's worth noting, by the way, that one of the same scientists contributed to this paper about babies that we're going to get to a little bit more in just a little bit, and then this language paper that they're citing. So anyway, so the short story is that this group found that similar patterns of brain activity were measured in a variety of brain regions between both Russian and English speakers. And so they made the argument that the human brain therefore likely processes actual events, this is a real life story, in similar ways regardless of language. And other studies have shown that effective communication arises from strong coupling between the activity in the listeners' linguistic and higher order brain regions and the speaker's own same brain regions. So in other words, there's this kind of synchrony that emerges within similar brain regions between somebody expressing a concept or a story and the recipients of those communications when that communication is made effectively. And so, keep in mind, this isn't limited to when people are listening to precisely the same stimuli, right? It's the similarity in brain responses, and they enumerate like the default mode network and the medial prefrontal cortex that generates a shared understanding, at least according to these sets of studies, or this set of studies. And I should mention the default mode network, if you're consuming information about the brain, is probably something that you'll hear more than once. And so it is one of the most widely studied brain networks. And basically what it is, it's like a network of brain regions that just tend to interact with one another quite a bit. And so in particular, it seems that this network is most closely associated with periods when we're sort of introverted, when we're like not focused on a particular task, or not when we're in conversation with a specific person, but when we're sort of just like thinking inward, daydreaming, or just sort of like letting our thoughts drift, right? Not focusing on any one specific thing. So the point that they're conveying with these studies is that we don't have to be taking in precisely the same sounds or even information in the same languages to experience shared patterns of brain activity when we understand things in similar ways. Or as Piazza, who is the first author of this baby study, said, quote, "Previous research has shown that adults' brains sync up when they watch movies and listen to stories, but little is known about how this neural synchrony develops in the first years of life." Okay, so now we'll get back to babies. So the way this experiment was conducted is pretty impressive. So they worked with 18 infants, aged, ranged between about 10 months and about 15 months, and it was half male, half female. And then there was a single experimenter with what they describe as extensive parenting experience, which they don't really describe what that means exactly. I'd love to know what precisely that means. Like, it'd be funny if that scientist had like 12 kids or something like that. But anyways, it was the same experimenter. And so the experimenter, though, and this is important, wasn't like in on the details of the experiment. She was aware of the overall concept, but not on the specific cues that would occur between the baby and the adult. So they wouldn't be as capable of biasing the progress of the experiment. All right, so, and here's how they actually like measured brain activity. And so here's a picture of what their device actually looked like, with the adult reading what has to be like, it must be the most common baby book in the United States at a minimum, maybe even outside of the U.S. And it's called Good Night Moon. And so I don't know how, but I think we've ended up with 3 copies of this book. It's a good book and everything, but it's pretty nuts how pervasive it is. It's not particularly special in any way. And so you can see the Goodnight Moon towards the bottom of the picture there, and then you can see, more importantly, the devices that were used in this study that are basically strapped to the adults and the babies' heads. And so you might have heard of fMRI, functional magnetic resonance imaging. But if not, you might have heard of an MRI, perhaps gotten one when you broke a bone or something like that. Well, fMRI shows changes in how metabolically active different brain regions are, giving us an idea of how active the neurons in those brain regions are, because neurons are very metabolically active and demanding. And so if you've had the good fortune of not having to visit an MRI or get an MRI or fMRI, here's what it looks like. And so you're basically lying down, wheeled into this hole of a gigantic donut, and you have to stay as still as possible. Right? Any movement will compromise the measurements that are taking place. And so what this study used, as you can see, they're not in any donuts here. They used a technology that's not as widely used called FNIRS, which is functional near-infrared spectroscopy. And so you can see that, again, instead of being wheeled into a giant donut while you're lying down, they strap a cap to the participants' heads. And so it basically enables super quick measurements that are similar to what fMRI measures, but only in the outermost regions of the brain. And so, it has advantages and disadvantages. And for a study like this, a huge advantage is that the subjects can sort of move around a bit, so it can feel at least a little bit more natural. And so, perfect for a study like this. And so here's what they did. So they strapped these FNIRS caps to the baby and the adult. And then the adult spent 5 minutes just generally playing, singing, and reading a book. Goodnight Moon, specifically. And then while doing so, the scientists measured changes in how metabolically active various parts of the outside of the brain became, moment to moment as the duo went through their various interactions. And then they also performed another 5-minute session that they called the apart condition, which is basically a control where the experimenter, that experimenter with prodigious parenting experience, turns away from the baby and then told a story to another adult experimenter using zero baby talk, right? So it's just like natural adult communication. And the baby just sort of interacted quietly with their parent. And so the reason they did these 2 5-minute sessions is so that they could ask a specific question, which is, were the patterns of activity in the brains of babies and adults more or less similar or no different at all when an adult and baby were communicating with one another directly? And so here's what they found, starting with a quote from that first author of the paper, this is Piazza. So while communicating, the adult and child seemed to form a feedback loop. That is, the adult's brain seemed to predict when the infants would smile. The infant's brains anticipated when the adult would use more baby talk. And both brains tracked joint eye contact and joint attention to the toys. So when a baby and adult play together, their brains influence each other in dynamic ways. So in other words, there's a kind of special pattern of activity that emerges when an adult and a baby interact, specifically because there's a bit of anticipation and a sort of primitive understanding of, collaborating on interaction with a given toy or whatever it is in real time. And so, that probably doesn't sound particularly like earth-shattering, that the brains of adults and babies exhibit special patterns of activity when interacting with one another. But what's special here is that there's a form of mutual understanding that's occurring between an infant and an adult. And it's occurring despite the absence of any meaningful communication via language, for example, which is, of course, quite important to the way adults interact with one another, right? We rely heavily on language. There was another interesting finding from the study, though. So as one of the authors, Lou Williams, who is the co-director of the Baby Lab at Princeton, describes, quote, "We were also surprised to find that the infant brain was often leading the adult brain by a few seconds, suggesting that babies do not just passively receive input, but may guide adults towards the next thing they're going to focus on, which toy to pick up, which words to say." And so it's also worth highlighting that there were specific cues that drove these moments of signaling synchrony, and they were largely social cues. So these were things, again, like visual gaze, facial expressions, like smiling, joint attention or moments of shared attention on a given toy or whatever, and a very interesting aspect of vocal communication called speech prosody or prosody. So prosody is something that's almost certainly very intuitive to you, but you perhaps don't even consciously consider. So when we're talking to one another, we're never truly monotonous, right? We have various inflections and changes in tone and changes in tempo and in intonation and so on. It's kind of why listening to Siri or Alexa is still so ungratifying, because no matter how sophisticated and amazing their capabilities are and how impressive the software engineers and programmers are that made them, they still just don't sound quite human yet. And so it's also, at least for me, part of why a language like Chinese is so difficult to pick up. Tonality is integrated into the language itself, so it's kind of sort of taken off the table of improvisational communication to someone, at least, who's learning the language with the tongue of an English speaker. Where if I say, "Hey," it's rather different than, if I were to say "Hey." Same word, intonation changes everything, right? So, to be honest, when I was in China, it was very apparent that there's clearly a version of intonation that's used among native speakers, and it's probably just my own naivete getting in my own way here. But anyways, it was these sort of somewhat intangible, or at least, it was the aspects of communication upon which we focus a bit less than the more explicit ones that seem to drive these moments of synchrony. After all, these infants, these babies couldn't speak words, right? Or, they couldn't carry on a conversation using words. And I have to tell you that in those moments that I described when I'm interacting with my daughter, playing with toys, playing music, or reading Good Night Moon, as it seems like all American parents are like legally bound to do, it's easy to develop a sense that there are at least moments of genuine communication, that she understands the basics of what I'm conveying, or, vice versa, in like very, very rudimentary ways. And so, this study doesn't necessarily validate that feeling, but it does indicate that there's something unique occurring when an adult and a baby communicate with one another. And so importantly, in the discussion of this study, the researchers highlight that these results, quote, emphasize not only the role of adults' input, but children's potential role in shaping their own input. And then later they highlight that these results expand on how we understand the sort of like, I might call nutritional components of how babies interact with parents by, quote, showing how adults and infants' brains reflect each other during natural social interaction, mediated importantly by sensitivity to each other's behaviors. And so, and then they go on. So overall, we found that prefrontal activity in the infant's brain slightly preceded similar activity in the adult's brain, despite the relative lack of overt behavioral influence exhibited by the infants. So, in other words, perhaps, unsurprisingly, there's a kind of reciprocal back and forth relationship between the brains of adults and the babies with whom they interact. And, I think it's also worth telling folks who like aren't in science that papers like these serve a sort of dual purpose. So first, of course, are the data, the findings that I just described, that reciprocal relationship between baby and adult brains. The second, though, purpose that they serve, papers like these are kind of like a proof of principle that the application of this technology, the simultaneous monitoring of brain activity from two people using specifically FNIRS, that technology that I described earlier using the caps that you can see in the bottom picture there, that this strategy can be used to ask new types of questions. And so, fMRI is essentially limited to one person at a time with extremely limited mobility. You're laying in a giant donut, staying as motionless as you humanly can. Innovation like these enable scientists to ask new sets of questions that wouldn't even occur to us prior to their existence. And so, I know that was absolutely the case in my own experience. When I first majored in neuroscience in college, the techniques that I ended up using for my PhD were in sort of the earliest phases of being introduced. And one of them literally didn't even exist until after I graduated from college. I'm specifically talking about optogenetics and chemogenetics, which enable very, very specific control of very specific neurons in very specific regions of the brain. Sort of like, it would have sounded like sorcery to me when I was in college. Optogenetics did have this sort of like magical kind of appeal to it when, I was first hearing about it at the tail end of my neuroscience major. And, I was fortunate to have a mentor in my PhD who was like adventurous enough to let me explore them despite the fact that they weren't really being used in the lab. And so when it comes to real-time measurement of some of the brain activity in two people simultaneously, it's innovations like the ones in this paper that will enable far more interesting questions to be asked, particularly as technological improvements are made, assuming we, continue to invest in basic science. And so, if you're a particularly pragmatic person who's not entirely impressed by the pursuit of knowledge as an end in itself, but rather you're more interested in how this knowledge can be used, these kinds of studies also provide for potential improvements in how we capitalize on the opportunities in those earliest stages of child development. And so, it's no secret that, just as an example, children can learn new languages far more effectively than adults. And that's due to the unique biology of those early stages of development in the brains of young people. The potential of these, early stages is really remarkable. And figuring out how it is that adults can most effectively educate young children can potentially expedite quite a bit of learning. And, again, one of the lenses through which I interact with my daughter is neuroscience. And, I'll admit that I occasionally fall victim to wondering if, some of the more like indulgent moments of snuggling and cuddling and, just silliness and getting her to giggle might be better spent. Like, it might be in her better interest, in her best interest, if we were to interact with some kind of challenging toy or puzzle or book or, vocal interaction, like trying to get her to learn new sounds. And, at this point, I don't think that any guilt from not doing those things is justified, at least from what I've read so far. But I can imagine a future with, a more completed neuroscience where there are various exercises, that are validated by research that are recommended for those very early stages. Just like there are, recommended exercises to learn the piano or how to hit a baseball. Okay, so that's what I have for you today. I'll admit I was up a bit late last night because I went to the park with the girls yesterday afternoon, and the baby was like enthralled with a swing, by the way. It took her a little bit to get comfortable with it, but once she did, she was all about it. And so, all the various things that drive me nuts if they're not done before I go to sleep kept me up, a little later than I would have liked. All right, anyways, let's start the live half. Hello, everyone. My name is Ian McLaughlin, and I'm a PhD in neuroscience. It's still strange to say that. And I just talked about an interesting study that came out of Princeton University on YouTube that described at least a component of how it is that babies and adults communicate, and identify that there are likely, degrees of depth to that communication that aren't particularly obvious, because babies can't really speak languages. I mean, they speak. My baby speaks a lot, but they haven't quite mastered language yet. So if you're interested in that, you can search. It's still kind of hard to find my channel, so you can say Ian Brain Science or Ian Anthropoid Science or something like that. It's a pretty cool study. It's like, I don't know, if you don't have children, then you might not be surprised that there are these moments when you're interacting with this tiny, tiny human that that feel like there's something special going on, like there's some kind of communication that's going on. But you always have to sort of scrutinize that speculation, because after all, how much can this little nascent nervous system really understand? And so this study kind of elucidated that a little bit, at least. All right, congrats. Well, thank you very much, Dave. I appreciate it. Yeah, it's been still kind of weird to not have the sort of the dissertation and defense and graduation looming over my shoulder. So, am I a millionaire? No, far from it. Most people do not go into basic science to become millionaires, although you can. If I were to go work in the private sector in biotech or something like that, then you could make a very comfortable living. It's just a different kind of it's a different kind of science, really. It's applied science, essentially. No, I'm certainly not a millionaire. Okay. If you say you are a brain scientist, what's the cure for depression? What should one do to get better? Okay, speaking of applied science, that is a multi-billion-dollar question. Because we have, of course, treatments for depression, but they're not particularly effective. They're not as effective as we would like, right? They're not as effective, for example, as giving insulin to somebody with diabetes. They're helpful, though. They're helpful for a lot of people, and it's better than nothing, certainly, and it reduces suicidality among people who are depressed. And there, of course, there's plenty of anecdotal evidence that people, it can make a huge difference in the quality of their life. So, however, as I opened with, there is certainly room for improvement when it comes to treatments for basically all psychiatric conditions, but depression in particular. And so, what's the cure? Well, we don't have a cure for it yet. Depression emerges from some of the most evolutionarily primitive parts of the brain. They're not easily accessed, and it's difficult to design drugs to target something that you don't even know the precise target, right? It's like playing darts, and there's a target somewhere in front of you, but you can't quite see the target, sort of like that. But some of the innovations in the treatment of depression and other mood-related psychiatric conditions that are sort of moving the ball forward. And so one of them, for example, is the discovery, essentially, that a drug like ketamine actually provides some substantial assistance, or at least alleviates the severity of depression for people who are quite severely depressed. That actually was it last year, I suppose. There was a new essentially medical device, a new delivery system for not ketamine, but an analog of ketamine called S-ketamine, very, very similar, that is delivered intranasally. And so there were clinical trials that were conducted, but I don't know that it's quite as widely used as some of the frontline treatments for depression, like the SSRIs, SNRIs. But, broadly, and then, of course, there's some evidence to suggest that the use of something like transcranial magnetic stimulation, TMS, applied to essentially like more frontal regions, more anterior regions of the brain, can be helpful for some people suffering from depression. And that's nice because it's non-invasive. It's just essentially putting like a very special and powerful magnet over a part of the brain and essentially like altering the firing patterns of the neurons in that region. However, stepping back, I think two things at least are going to enable us to develop much more effective drugs, much more competently, or treatments, I should say. The first is, and I talked a little bit about this on the YouTube, some of the new techniques that have been introduced and integrated into modern neuroscience are enabling us to ask way more specific questions about how the brain works and how the brain regulates mood and emotion. And a lot of those questions are going to enable us to pinpoint specific networks of neurons that ought to be targeted to modify their specific firing patterns. And so I know that probably sounds a little bit abstract or nebulous, but we have 86 billion neurons, right? About and hundreds of trillions of synaptic connections between them. Specific groups of that 86 billion neurons participate in specific things. Some of your neurons are devoted to vision, some are devoted to maintaining balance, some are devoted to hearing things, and some are devoted to regulating mood. But it's not like there's just one brain region that regulates mood. It's a whole constellation of brain regions. And even within brain regions, only some of the neurons in those brain regions are implicated in the regulation of mood and depression rather than, let's say, bipolar disorder. And so as, this basic neuroscience continues to progress, we'll be able to devise drugs to target those specific neurons that we discover are specifically involved in depression. And, another one, and so I said, two things, that basic neuroscience progressing as it is will help us develop better treatments. Another is the, exploration of totally new categories of medications. So, for example, people with post-traumatic stress disorder have been shown to respond pretty favorably to clinical treatment with MDMA, methylene dioxymethamphetamine, or Molly, or ecstasy. And so, these studies have been pretty compelling. And, MDMA has somewhat similar pharmacology compared to fluoxetine or Prozac, but it's pretty different. And it's stimulating, and, the way it influences serotonin signaling is slightly different, but it is, it's targeting many of the same brain regions of brain, circuits of neurons, but it's sort of tickling them in a slightly different way. And when combined with psychotherapy, can be very profitable, right? If you're trying to treat depression. So, exploring novel pharmacological categories, again, that's like ketamine, or S-ketamine, but then also as basic neuroscience advances, we're going to be able to develop something that resembles a cure rather than just a component of an effective treatment strategy. And then, as always, confronting the brain on its own terms is typically pretty effective from a clinical perspective. And so, just giving somebody an antidepressant is suboptimal. It would be preferable if you could combine multiple treatment modalities. Pharmacological, if the physician and the patient decide that's what's best, and psychotherapy. Okay. When do you expect the final FDA approval for MDMA for PTSD? I don't know. I mean, it's pretty close. So right now, an organization called MAPS is essentially spearheading the clinical trials for MDMA. And, they are a pharmaceutical company technically, but they don't operate like, your run-of-the-mill pharmaceutical company. They're almost nonprofit. And so as a result, they basically operate based off of donations. The last time I checked, they had, I think, amassed something like 99% of the funding that they need to conduct their final phase 3 clinical trial. Phase 3 clinical trials are extremely expensive. On average, it cost about $2.2 billion last time I checked to bring a drug from early phase 1 all the way to, the shelves in your pharmacist's pharmacy. And so all this to say, they're quite close to essentially, demonstrating MDMA safety, efficacy, and so, but how long it'll take? Clinical trials can take a very long time. Just to get enough people in the study who fit your recruitment criteria, like, you don't have schizophrenia, you don't have a history of, drug abuse, or you do, if that's relevant to the study, etc. You need a specific kind of candidate to conduct an effective clinical trial. So it takes time. I would imagine, certainly within our lifetimes, I would imagine within the next 5 to 10 years, I wouldn't be surprised if we see MDMA becoming a more regularly prescribed medication for psychiatric conditions like PTSD, potentially other ones too. Ian, do you miss me, Hulk Smashed? Of course I do. I think about you day and night, Hulk Smashed. All right, somebody's calling in. Miguel. Oh my gosh, where's my pen and paper? Miguel, is that your name? And if it is, where are you calling from?
Yes. Hello from Colombia.
Hi, cool. So Miguel from Colombia. What's on your mind?
Oh, good, brother. You are in Philadelphia, right?
Yes.
Are you a doctor?
I have a PhD.
Nice.
It took a while, yeah. But what's on your mind?
No, I don't know. I mean, it's always interesting watching you, because we learn a lot. I'm actually taking right now this medication that is lithium.
Lithium. Oh, yeah, sure.
Carbonate lithium.
Sure.
And it helps, brother. It really helps.
Yeah, well, I'm glad to hear that. Yeah, lithium is prescribed for a handful of psychiatric conditions. What's interesting about lithium is that we actually don't know precisely how it works. We know that it's effective for certain patients. There's speculation that it might sort of alter the way that ions flow in and out of neurons. But in terms of a much more specific, we have a pretty good explanation for how like fluoxetine or Prozac works. But when it comes to lithium, we don't have a really precise explanation. But as you say, it is pretty effective for certain conditions. So I'm glad to hear that, Miguel.
Yeah, it is. Thank you, man. It's something very new, but I believe if the person wanna try something different, and wanna take the risk, I think it's worth it, to try with some of these medications to see what can change maybe in your life within 4 or 5 months. Nothing is gonna change in 2 months. You have to give it maybe like 5 months, 6 months, maybe a year, if you wanna feel something different and see maybe some other things. But it's very tricky, at the same time it's very tricky because you never know, what way this can be with that type of drugs,
I couldn't agree more. Yeah. Listen, Miguel, thanks for calling in, and I appreciate you sharing your experience.
Thank you, man. Have a good one.
You too. Some of my good friends in high school. I went to high school in Miami. We're Colombiano. All right, we have a question from YouTube. So, have you been? Oh wait. Oh man. Have you been able to enjoy playing your guitar for your daughter? How did she react to that? P.S. So great seeing how excited you are to be a dad. Incorporating science with is more awesome. Thanks for sharing with us. Oh yeah. Okay. So yes, actually very, very early on, like for the first basically 3 months, an infant is just a total potato. Like it just cries, poops, eats, sleeps. But sometimes sleep doesn't come as easily as you would like. And that was our experience. I probably starting at about 3 weeks, I started playing a specific song on the guitar. It's by John Butler, and it's called Ocean. And it's sort of like a long instrumental song. It's about, it varies. He sort of improvises, but it's about 7 to 12 minutes long. And it would at least calm her down enough to stop crying if she was crying. But then as she got older, she clearly started to recognize certain sort of components of the song. And she would sort of immediately look when I got to a certain point, and now what's adorable is she does this little boogie move. She just sort of goes like this when there's music playing, not just when I'm playing the guitar, pretty much any music, which is super cool. Yeah. So if you play the guitar or you play any musical instrument and you're struggling to get your infant or whatever to calm down, give it a shot. I suspect in the earliest phases, it's just sort of dominate that sensory input. dominates whatever's causing their, their arousal or their aversion, and just sort of like resets. It's sort of like, when a baby is crying. Here, we have a very small apartment, but we have at least, we have 3 rooms basically: bathroom, bedroom, and then the living room, kitchen, family room, blah blah blah, all in one. But if she starts crying in one room, if you just basically immediately pick her up and go into another room, it basically stops, because I suspect it's just a new context, new sensory environment, and whatever emotional processing was occurring in that former room, which is always associated with an environmental context, a sensory experience, that emotional processing, it resets. And now this is a new context. New emotions can come to pass. And so, those are my 2 little cheat codes. All right. Well, thank you very much, Hulk Smashed. By the way, I've been watching you a while. Oh, that's awesome. Big AI, your pal. Big Al, your pal. Duh. You can probably tell what's on my mind, AI. Well, thanks, man. I appreciate it. Psychiatric nurse here. Now, I mean, so this is probably pretty well appreciated, but it's never more clearly demonstrated than when you are delivering. Well, I wasn't delivering the baby, but when parents are delivering a baby, when a woman is delivering a baby, and you sort of see the roles that nurses and physicians play. Man, I mean, nurses are so much more useful. And particularly after the baby is born, we saw several physicians, and of course they were very insightful, and they weren't there to help us, just broadly speaking, but it was a nurse who finally basically gave us the knowledge, the wisdom to help our baby our infant finally stop crying. And it was just like flipping a switch. And had we not interacted with a nurse, who knows, the baby might still be crying. And in psychiatric clinical settings, that is just enormously challenging. I remember in grad school, before I got married, I dated a girl who was an MD PhD student, and basically the way you do that is you do your first 2 years of med school, and then you do your PhD, which is usually not abbreviated, usually a little bit shorter than just a pure PhD, and then you finish your medical stuff. And so and therefore I hung out with a bunch of med students, and they all said that it was the psych rotation that was just this ring of fire, man. It was like so difficult and challenging, like emotionally. So yeah, a lot of respect to somebody, particularly like a psychiatric nurse, for working in that environment, making it sustainable. So Flocka makes you a real zombie. So Flocka is an interesting phenomenon. I don't think that it's actually that terminology is still very widely used, but a few years ago, Flocka sort of became a term that was applied to basically gray market designer drugs or research chemicals. They're now sort of more commonly called. And these are basically like analogs, typically of MDMA, but basically it's just like variations on the amphetamine molecule. MDMA is an amphetamine, methylene dioxymethamphetamine, or manipulations of like the tryptamine molecule, but most broadly for what was most commonly used at the time were basically amphetamine analogs. And Flocka, in the case of Flocka, I think most commonly it was when you look at the sort of gray market for these recreational euphoric stimulants, they sort of come in waves, and this is because a big amount will be synthesized, most commonly in China, but other parts of the world too. It's just China's a very, very big country, and so as a result, the market gets flooded with a specific designer drug or whatever. And I think when Flocka was in its heyday, generally speaking, what composed Flocka was alpha pyrovalerone, which is, it's not quite an amphetamine, but it's very, very similar in its effect. But Flocka, it didn't necessarily refer to one specific drug, which is sort of what happened to the term ecstasy, many, many years before that. Ecstasy came to just be referred to a pill that you got on the street that was stimulating and somewhat, euphoric, and, but pill testing groups found that it was very rarely actually MDMA. Anyway, so, but what's interesting, the whole connection between Flocka and the zombie thing was that there was this tragic and alarming event in Florida. No surprise there if you've ever lived in Florida, like I have, where there was this guy who very, very violently attacked another guy, and he just seemed so out of his mind And it was around that time that, Flocka and, bath salts at the time was also very widely used. And there was just this assumption that this guy had taken Flocka or bath salts or whatever. It actually turned out that he had not taken any of those drugs. And so it was like just this miscommunication, just inaccurate reporting, I guess, that caused people to like just call Flocka the zombie drug. And I mean, I don't advise anybody to take it because you have no idea what's in there, but there's actually no evidence that it turns you into a zombie. So there are, however, if you want to go down a very freaky rabbit hole, there are videos of people, and this was quite common when synthetic cannabinoids were just sort of flooding the market, where people would take these drugs and then really behave in very strange ways, not like people who get stoned, So synthetic cannabinoids are made essentially to deliver some similar effects as, cannabis or THC. But because they're synthetic and very understudied, and these were drugs that were initially designed to help people who are undergoing chemotherapy, to stimulate appetite, do a lot of the things that are beneficial that cannabis can do. But of course, as always happens, they infiltrated the street market, and you had like K2 and Spice, and these are all synthetic cannabinoids. But because there's like no quality control for these drugs, people could get just these gigantic doses. Oh, the other thing is that they're oftentimes, not always, but oftentimes way more potent than THC. And so it takes just like a tiny, tiny little bit to really blast those cannabinoid receptors. And that's what would happen. And so you can see like these people just sort of totally in the state of psychosis. But that was not Flocka. All right. Sorry, I'm going on a little too long. Hey, Leonora. Good to see you. Chinese fentanyl seems to be going gangbusters. Yeah, so that is something that I was almost going to talk about today. So that's absolutely right. Fentanyl, there's this really, really excellent article in, I think, New York Magazine, where the reporter basically just follows the line of this fentanyl got on the street in, I think it was Ohio, a specific case, a specific guy who ended up losing his life because he was a heroin user, but he ended up using fentanyl, which is quite frequently what happens when people overdose and die, is that what they thought was heroin actually contained fentanyl, and fentanyl is significantly more potent than essentially any other opioid that you would have heard of. And so it's impossible for them to really accurately gauge their dose, even for people that use heroin every day. And so they die. But so this reporter tracks this fentanyl all the way back to China. And the story is wild because, on the end of China, like for, at least in this case, basically it was like a commodities guy who was like selling teddy bears and, pencils or something, just random, commodities, to the U.S. market who, was introduced to the immense profitability of fentanyl. He ended up trafficking in fentanyl. And yeah, it's just, it really illuminates a lot of how these markets work and how almost impossible it's going to be to stop this. And I think a lot of misguided reactions happen at the level of government. Like, okay, we need to ban fentanyl. That was a recent article, op-ed in the Washington Post. And that is the wrong approach. For a variety of reasons. And, I can get into them if you're interested. But yeah, I mean, what we need is a completely different approach to solving, or at least confronting, this challenge of opioid addiction, which is, resulting in an unprecedented number of people losing their lives every year. Like truly massive numbers of people dying every year, like Vietnam conflict, Vietnam War era fatalities, just from, and fentanyl is the sort of driving force behind this dynamic. It's not exclusively fentanyl, but it's a main contributor. All right, the neuropathology of drug addictions and substance misuse. I think I'm published in that journal. I'm not sure. Hello from Iran Army. What is your opinion on Ritalin as a medication, not for recreation? So Ritalin is an interesting drug. It's among the more widely studied just because it's easier to get than amphetamine. Ritalin is, of course, the active ingredient of, the active ingredient in Ritalin is methylphenidate, which is also the active ingredient in Concerta. And what do I think? It's remarkably effective for treating ADHD. Ritalin, both Ritalin and Adderall, they have very, very similar pharmacologies, not identical, but similar. There have been many, many efforts to try and figure out an alternative approach to treating ADHD. And it just has turned out that no other strategy, behavioral interventions, dietary interventions, they can help, but nothing has been able to, to surpass the efficacy of these psychomotor stimulants, Ritalin and amphetamine. And so, it's important to note that somebody with ADHD will react to these drugs in several different ways, relative to somebody who is not, diagnosed with bona fide ADHD. What do I think? It doesn't really matter what I think, in terms of like their utility. They're effective at helping people who would otherwise struggle, prohibitively. It would be prohibitively difficult for them to participate in, school, in those early critical years of education. It enables them to function with a higher quality of life. So that's, very helpful. I sympathize with people who are alarmed by the reality that it is almost certainly overprescribed and misused very widely, particularly in colleges. But that doesn't mean that it is just like, it doesn't mean that it has no medical utility whatsoever. So what do I study? So I just finished my PhD, and it was basically in the neurobiology of mood, anxiety in particular, and addiction. And so when I say neurobiology, like trying to characterize how specific circuits of neurons in the brain, very, very ancient neurons that have been in an animal of some sort on Earth for at least 350 million years, how it is that this brain region might sort of participate in determining whether or not an animal, and a human too, is likely to be anxious, and how that might contribute to predispositions to addiction. All right. What do you think about self-medicating ADHD by using amphetamine? Self-medication is it's probably not prudent because it's very difficult because of some of the unique properties of those psychomotor stimulants, that they are euphoric for many people at least. It can be difficult to maintain control or discipline over that dosing, and that it's very helpful to have somebody who has a well of experience from which they can draw to help you manage ADHD. Okay, how does the third eye work? So in neuroscience, we don't really use the term third eye. Sometimes neuroanatomists can get a little playful and refer to certain brain regions just because of their phylogeny, because of comparative anatomy. When we look at this brain region in other animals, it does resemble an eye, a bit. It does resemble something that could have developed into an eye had evolution taken a turn this way or that way, and that is the pineal gland. The pineal gland in the human brain is extraordinarily small. It participates in regulating circadian rhythm, synthesizes melatonin. You might be familiar with melatonin. And in concert with other brain regions like the suprachiasmatic nucleus, sort of contributes to a bunch of physiological cycles that are, hormonal cycles, appetite cycles, energy levels that are, at least in part, determined by where the sun is, essentially, how much light there is outside. But the reason that at least one of the reasons that it's taken on this kind of like mythical status in terms of brain anatomy is in very distantly related, evolutionarily speaking, organisms. What is likely the equivalent of their pineal gland is located sort of right underneath the skull. It actually is photosensitive. So it does receive, signals from photons stimulating it, and quite likely plays a very similar role that the pineal gland in our brain does. The pineal gland in our brain also receives signals from our retina, from our eyes, that essentially it's like the amount of blue light that you're exposed to influences pineal gland signaling. And by the way, the brain region that I study, one of the brain regions I study, used to be conceived of as being like the stalk of the pineal gland. So it sends signals to the pineal gland and so on. But outside of neuroscience, I think the pineal gland has taken on way like a disproportionately mythical, presence essentially in sort of like the popular consciousness, popular imagination. And at least part of this arises from some speculation by, decades ago at this point, by a guy named Rick Strassman, that perhaps within the pineal gland, a psychedelic drug is produced, dimethyltryptamine, DMT. It's important to note that, there is no evidence that DMT ever reaches substantial concentrations in the brain, right? There have been studies that found trace levels of DMT in the brain, but that trace levels is very, very important. That means that it never really reaches the same concentration as like dopamine or serotonin or so on, which indicates that it's probably not playing a very dominant role in determining much of anything. Some of the speculation is that it might play a role in sort of regulating intracellular signaling. There's a ton of proteins and peptides and molecules that do that, regulating, for example, how much calcium is available to the cell. But yeah, like it was like this initial speculation that's very romantic, and it kind of does make intuitive sense. How do we have dreams? What is a near-death experience? But there's no reason that we need for there to be DMT present in our brain for any of those things to happen. We have perfectly adequate explanations and more parsimonious explanations for how it is that we have dreams, why it is that we have dreams, and what a near-death experience is likely generated by in the brain. So that's a long spiel. All right. Congrats on graduating. Thank you very much. It took me long enough, but yeah, I'm officially done. All right, we're getting a caller. What's your name and where are you calling from? Are you there?
Hey, my name is Zane.
Sane?
And I'm Zane with a Z.
Oh, Zane. Oh, gotcha. Of course. Okay, Zane. And where are you calling from?
I'm from Pakistan.
Cool. Zane from Pakistan. What's on your mind?
Nothing much, man. Chilling. What about you?
Well, I just chatting about stuff related to the brain. We can talk about anything from dreams to how various drugs work, how addiction works. Déjà vu used to come up all the time.
Yeah. I have a question, actually. This is great that I stumbled upon you.
Cool.
So, you know how, for example, there are people out there who watch graphic stuff?
Yeah.
Right? Like beheadings and all that kind of shit.
Yeah.
And why do they find pleasure in that is my question.
Yeah, it's super interesting. And you'd probably be more gratified by an answer from like a psychologist. I would imagine that when, humans are social species, we rely very heavily on social interaction, and part of how we interact socially is empathetic reactions to the experiences of others. And empathy is sort of a more neutral term than I think it's used widely. It's sort of, I think, widely appreciated as just like a fundamentally positive thing, and it's not necessarily. But what that empathetic capability enables us to do is sort of experience a dose of somebody else's emotion or experience. And when it comes to, day-to-day life, particularly for people that, whatever, they have time on their hands. They could play video games, they could, watch movies. Eliciting those very, very arousing emotional experiences, I think in and of itself, in a safe context, right? That there's no threat that somebody's going to come behead you, right? But you can watch this highly arousing, I don't mean arousing in a sexual way, like arousing, like it causes you to have a little bit of fight or flight. I think at least partly explains why people are driven to watching those grotesque videos. But I mean, if I watched Saving Private Ryan a few months ago, and it's super graphic, like it's very intense, and it's considered to be one of the best movies of all time. And so, I imagine that that's at least a part of it, that, it enables us to tickle these emotions that aren't really available to us in our rather safe daily lives. But beyond that, I imagine a psychologist would have a better explanation for you.
Yeah, that was a dumb question on my part because that's not really your field. But I thought, you were available at the moment, so I thought, why not?
Yeah.
Well, it's good that you're doing this, It's very interesting.
Yeah, well, it's my pleasure. But anyways, thanks for calling in, man. And hope to talk to you again.
Yeah, sure. Take care.
Take it easy.
Bye bye.
Zain from Pakistan. Very cool. Sergeant Ian McLaughlin killed in a roadside bombing in Afghanistan Saturday. Are you serious? Whoa. That's awful to hear. Jeez. Okay. Microdosing LSD is something special. No social anxiety, great focus, confidence, etc. Yeah, so orange utang or orang. I'm just going to say orangutan. Yeah, microdosing is a very interesting phenomenon, and it does seem that it is achieving a bit more popularity, or at least more people are aware that this is a thing that people do. So microdosing, for anybody who's not familiar, is exactly what it sounds like. You're taking sort of fractions of the dose of a drug that would typically be taken at higher doses. And when it comes to LSD, LSD is an extraordinarily potent molecule. You know, when it comes to, you know, amphetamine, for example, 5 milligrams, 10 milligrams, 20, 30, 40, blah, blah, blah. You're sort of in that milligram range. When it comes to LSD, you're in the microgram range. And that's why oftentimes LSD is dosed on blotter paper, because you just have to put just a little droplet of water or, you know, liquid with LSD suspended in it on paper, and then you absorb everything you need from just that tiny little bit. So when it comes to microdosing LSD, you're microdosing micrograms of, you know, a very, very potent drug. People also experiment with microdosing psilocybin, which is in sort of the same broad family of drugs, psychedelic hallucinogens, has kind of a similar pharmacology, in fact, despite the fact that these molecules are very, very different. But, you know, delivers many, many of the same pharmacological effects. And, you know, there's a lot of interesting anecdotal evidence out there. And, you know, generally speaking, it tends to be quite positive. From my perspective, you know, when I look at the pharmacology of a drug like LSD, it's just a mess. Like, it has such broad pharmacological action. It touches so many different parts of the brain that regulates so many different things that I would just be sort of freaked out that, you know, it's sort of a volatile drug. And of course, for people who, you know, are otherwise psychiatrically healthy, you know, don't have a family history of depression or bipolar disorder or, you know, psychosis, schizophrenia, this perhaps is not a concern. But for people who do have those histories, you know, LSD, psychedelics in general, can be potentially a problem, potentially hazardous to consume. And, you know, this is true for all drugs, I should say. But you know, it's not like LSD or psilocybin occupy some sort of like, you know, vaulted, you know, pillar of benignity, right? It's like, you know, there are costs and benefits to taking any of these drugs. But, you know, microdosing, there's a really extensive review that I've been planning on reading about for microdosing. And hopefully I'll get to that this week because there is some scrupulously collected evidence regarding microdosing. And it is intriguing. You know, I find the psychedelic hallucinogen family of drugs to be extremely interesting. And, you know, quite unique compared to essentially any of the other drugs that people do voluntarily, you know, alcohol, nicotine, and so on, even cannabis. We have learned quite a bit about how the brain works by evaluating or learning from how LSD alters brain activity and how that altered brain activity is associated with altered states of consciousness, right? You know, the wave specifically, in particular, how it modifies sensory processing, you know, how it is that a drug like LSD can influence sensory perception, visual perceptions, why it is that the walls can sometimes breathe, and why it is that the, you know, hallucinations associated with psychedelics are pretty different from those that are associated with drugs like ketamine or deliriants. So, you know, deliriants like diphenhydramine, by the way, which is available over the counter. So we can learn quite a bit from these molecules. But yeah, I mean, at least, and this is my own personal perspective at this point, I just don't think that we're at a point in the neuroscience, neurobiology of these drugs for it to be a kind of the risk-benefit ratio to microdosing with these molecules, I think still favors risk. Okay, how do I know a lot of everything? Well, I don't. The reality is that it's my job to know a lot, or as much as I can, about the brain. And not a lot of people have that privilege of getting to spend their days learning about the brain, conducting experiments about the brain, or on the brain. You know, you bring me outside of neuroscience and I'm useless. Totally useless. And so I think it's just the fact that this is a sort of rarely studied still within broader society that I come across as much more intelligent than I am, because I assure you, I am no more intelligent than you. You know, science is just like another job. Of course, there are a lot of brilliant people who are scientists, but by and large, they're just normal people. We're just normal people that happen to focus on this thing that most people don't focus on. So, all right. Okay, well, I smoke weed every day, and my brain cells ain't here. Well, it's not quite true that cannabis... there's at least no good evidence that cannabis actually damages neurons, but there is plenty of evidence that long-term cannabis use does influence changes in sort of like the overall anatomy of the brain, specifically white matter volumes. There's not a lot of evidence that those changes are permanent, but they can be quite long-lasting. And of course, for some people, cannabis, particularly people with a family history of psychosis or depression or psychiatric conditions in general, cannabis can be significantly more problematic for those folks than people who are the majority, people who don't have those histories. All right. I have one serious question: how to shut off love sickness. Oh man, sorry to hear it. I've been there. I empathize. This would be a great topic to bring up with a psychotherapist or a psychologist. I did a podcast on the neurobiology of love. The podcast is called Wired to be Weird. The episode is called Why Do Birds Suddenly Appear? That was when I was a little bit more playful with my titles. The subsequent titles are not so like, what are you even talking about? By the way, 1,000 points to Gryffindor for anybody who knows why I chose Why Do Birds Suddenly Appear? But anyways, there is a lot of neurobiology that can help us to understand why it is that humans fall in love. It is a pretty thoroughly irrational state. And in fact, there are like some interesting cognitive neuroscience or like neuroimaging using fMRI to identify basically broad changes in regions of the brain that become metabolically active and therefore likely neuronally active, comparing people who are in love to people who have a psychiatric condition. And there's some interesting similarities, but ultimately love is this invisible hand of natural selection that motivates us to engage in pretty thoroughly irrational behaviors. Like I would very willingly sacrifice my life to save my baby. And of course that's not in my personal best interest. But it is this, that of course that's not romantic love, but romantic love has similar effects, right? It motivates you to engage in these irrational behaviors. So you can check out that podcast, time and meeting new people. That's what's worked for me personally. That's not a neuroscience answer though. So yeah, Karen Carpenter's song. Yeah, that's right. Yeah. Points to Gryffindor for you. Okay. Getting a call from, I think, Farside. All right. It looks like we're having a little bit of trouble connecting. So what's your name and where are you calling from?
How's it going? My name is Farside, or aka Craig. I'm from South Africa. I'm a professional underground club DJ and radio DJ. And yeah, how's it going? Loving listening to you, finding it very informative. Just like you say, it's your job, but nonetheless, it's a job that not many people do, and it's nice to meet a person that isn't biased with regards to, neurotropics and narcotics and that type of thing is prepared to actually talk about. I could essentially ask you quite a few questions, and I could essentially relate to quite a few things that you've just spoken about. Let's just say I was a career druggo, 17 years, hardcore cocaine and crack abuse, eventually ending in heroin, and then eventually died after 17 years of just like daily obliteration, in volume and like with the determination and persistence to just use and use and use. Right. Anyway, so I died. Let's just skip the whole story of it and just say I died, and I did die. I was clinically dead. Came back and essentially decided enough's enough. So what happened was, within 10 days of dying, I managed to abandon crack, cocaine and heroin, gave it up, and I've been clean now from these drugs for over 4.5 years.
Wow, congratulations.
Right,
That's no trivial accomplishment, man.
Thank you very much.
Yeah.
So I basically was I've been well for the fact that I had like a idyllic memory and also basically photographic memory and that type of thing. And I'm a fairly sharp and intelligent person, well spoken, educated, and that type of thing. And what I found was once I had basically come to terms with the fact that I'm going to stop and that's it, basically, threw the towel in. I was sort of given a few months to actually just basically sit on the couch and vegetate and just sort of deal with my shit, excuse my language. And basically, I did quite a lot of research on what I was going to expect, and there's not a lot of sort of like real sort of like a this is what you can look forward to now type thing. But what I did find is they talk about the pink cloud. I don't know if you don't understand what I'm talking about. You understand the terminology, the pink cloud?
The pink cloud. No, that's not familiar. What is that?
Okay, so would you agree that if you are sort of like an ardent hardcore drug user, you sort of get to the point where you become sort of essentially deadish inside, and your ability to sort of like push situations and push them deep and not sort of deal with the implications and that type of thing, you manage to sort of just justify things to yourself and keep on going, right?
Sure.
Cool. So you become so good at it that it becomes second nature, and of course after years of doing it, you essentially don't really take into account the complications, the situations, the effects, that your actions take on yourself.
Absolutely.
And others. So, all right, fine. So what happens is, and this is something that I just want to share with you guys, is they talk about the pink cloud, and the pink cloud, they say 21 days, 3 weeks, basically, is when the pink cloud pops. Now, if anyone has ever basically been an addict and basically sort of try to stop in this type of thing, this is essentially where a lot of people fail, and it's this: you become so elated in the fact that you sort of a day clean, then you 2 days clean, then you're 5 days clean, and eventually you get to 14 days clean, and it's like, oh wow, it's the first time ever, or the first time in years, and the happiness of every day sort of dawns on you, and you get bold. And then what happens is essentially you kind of withdraw entirely, but you don't really sort of feel it. But one day you wake up and it's about 3.5 weeks in, and all of a sudden every sort of thing that you've pushed down comes rushing through. So every emotion, every thought, every sort of consideration, every action, every sort of repercussion that you've done over the time period, all of a sudden comes rushing at you with this and all of a sudden you have to deal with it on an emotional level, and you've become this emotional zombie.
Right.
And all of a sudden it becomes so overwhelming that you basically either slide into depression or you basically go back to using.
Right.
Luckily I read up on it, and I didn't quite sort of I didn't quite take it to heart until I realized it was happening to me. And so I just wanted to share that with you.
I really appreciate it, Craig. I mean, a far side. So that's a really, really excellent explanation of some of the psychology that arises after that really acute phase of withdrawal, which I think most people, that's what they focus on when it comes to quitting an addiction. But that extended period, that's when the really, really difficult period starts. I really appreciate your explanation, man. Thanks for calling in. I hope to talk to you again.
Your pleasure. Thank you. Have a lovely evening.
You too.
Bye.
Yeah, the pink cloud, that was like familiar. Of course, we don't refer to, in addiction neuroscience, we don't like use that terminology. It was familiar, and what he's describing is super common. It really, we're lucky to have somebody describe it that way. Okay. So are humans actually intelligent? Yeah. Humans are pretty remarkably intelligent. Now humans are capable of quite a bit with that intelligence, though, which I suspect is what the thing to which you're referring. Anybody from Australia? Oh, cool. I'm not, but is it possible to become intelligent, talented, smart, or is it an innate genetic characteristic? It's a controversial topic. So intelligence research kind of predates modern neuroscience. Intelligence has been, studied for a long time. You can make different, it really depends. It's kind of like an arbitrary, initiation of modern neuroscience. Aristotle wrote about, lucid dreams, for example. That goes back pretty far. But modern neuroscience is sort of like a newer phenomenon. But so because intelligence research has gone on for a long time, it does sometimes kind of operate in its own like silo. And so there's a lot, and initially there was not very much biology or even genetics research integrated much at all. And given the inception or the integration of neuroscience into intelligence research, things have become more difficult or less clear, right? So for a long time, the accepted wisdom was, genetics plays a dramatically dominant role in determining intelligence as measured by the IQ test. So the IQ test, it has been around for a very long time. And, initially it was very confident, or not initially, but it came to be used very confidently as a measurement of intelligence. As time went on, however, it was sort of appreciated that it is measuring a component of intelligence, arguably an extremely important component of intelligence, but not intelligence in its entirety. And, something as complicated as human intelligence requires a very nuanced approach. And only fairly recently have, scientists collaborated or at least exploited the tools of, other fields that have really useful tools on their tool belt, like psychology or, sociology, economics. And so one of my favorite intelligence, researchers who touches on intelligence is named Elliot Tucker Drob. And I can't remember, I always forget if he's at like Emory. I think he's at Emory University. And I think he used to be in Texas, but I might be, it doesn't really matter. And what he, once you begin to integrate more features of, human variability, socioeconomic status, parental exposure, how parental, parenting strategies, how many books one is exposed to early on in life, then it becomes a little bit clearer that the environment plays an extremely important role in sculpting what, we measure as intelligence. And so, the initial question is, can somebody develop intelligence, or is it genetically determined? There are certainly features of our neuroanatomy that are genetically determined, but I don't think that there's nearly enough evidence for somebody to suggest that it's essentially pointless to try and improve upon one's intelligence, right? Ultimately, this is a nature-nurture question, right? Meaning, is it essentially entirely inherited from one's parents, or is it sort of cultivated and nurtured by the environment? And it's, as is almost always the case in neuroscience, it's a little bit of both, and quite a bit of both. So I think, this is now my speculation just based off of what I've read from the various fields that participate in intelligence research. I think there are fewer and fewer researchers out there who will confidently still maintain that intelligence is almost entirely genetic. There are more and more neuroscientists who will argue, no, there's more going on here. And when you're only using this one crude tool, the IQ test, coupled with very, very crude or rudimentary statistics, you're just not sensitive to other points of variability here that also determine one's intelligence. So it's a really interesting question, of course. But yeah, I think we're sort of beginning to crawl from the mire of fairly rudimentary strategies in understanding intelligence. Okay, so what someone like yourself needs to really research is the effects of heavy cannabis use and the way it suppresses REM sleep and causes no dreams. And then when you stop or wake up and go back to sleep, the dreams are so vivid that they awaken you. Misconception of time happens as well. Well, that is a pretty well-established phenomenon. I mean, it's not only true for cannabis, though. It's true for essentially pretty much any mood-altering drug. Like alcohol, for example, interferes with your progression through the various, sleep phases. And if you're unfamiliar, an abbreviated explanation is that as you're falling asleep, you sort of progress from stage one, it's essentially you're progressing through slower and slower and more rhythmic patterns of brain activity until you reach stage 3/4. There's some scientists who argue that there's really no such thing as stage 4. It's just like, it's all stage 3. Who cares? It's just like a slower, it matters from an academic perspective, obviously. But, ultimately, you're sort of progressing through these slower and slower waves of activity until you reach REM sleep. And REM sleep, when you measure somebody's brain activity when they're in REM sleep, their brain almost looks like it's awake, right? It's a pretty stark distinction from the slow wave activity phases of sleep, stage 1 through 3/4. And essentially, alcohol notoriously interferes with the progression of, from stage 1 to REM sleep. And essentially all drugs do. That's also true for benzodiazepines, other drugs that are used even as sedatives that will help you get to sleep, but sort of interferes with that progression. And it sort of subtracts a bit of the nutritional components of sleep because, there are important biological phenomena that occur only when we're in slow wave sleep, only when we're in stage 1, 2, and 3, and 4. And then some that only occur when we're in REM sleep. And so when you say, heavy cannabis use, the same thing could be said for heavy alcohol use. Interestingly, however, nicotine seems to have a slightly different effect on dreams in particular. So I don't know that there's actually any rigorously conducted science on this, but there's tons of anecdotal data that, taking nicotine before one goes to sleep, it can make it difficult to fall asleep. But dreams under the influence of nicotine apparently are significantly more vivid, which is quite interesting. And it's perhaps unsurprising because one of the various sort of patterns of brain activity that are important to sustaining sleep and regulating sleep is cholinergic signaling. And cholinergic means acetylcholine-related signaling. And nicotine binds acetylcholine receptors. It typically, and acetylcholine receptors are all throughout the brain, one of the most commonly expressed receptors. They're also in the body, of course, but also in the brain. And so perhaps it ought to be unsurprising. But anyway, so when it comes to, cannabis and alcohol pharmacologically are really quite different. But they do share one thing in common, which is, generally speaking, the end result of their pharmacological action is inhibition of neuronal activity. Cannabinoid receptors are very, very different from the very, very wide range of targets that alcohol interacts with. But so as a result, you are suppressing some neuronal signaling. And when somebody's using any of those drugs for a very long time, your brain becomes accustomed and adapts to the chronic presence of those drugs. In other words, your brain changes in response to the chronic presence of the drug. And then when you take that drug out of the equation, your brain rebounds, right? It's used to having this molecule there essentially all the time, almost like it's a neurotransmitter. And so as a result, once you remove that drug from the equation, the brain has to change again. And part of that can be, these overly vivid, absurdly vivid dreams. And so I don't know that anybody is specifically studying, maybe they are, it could just be my lack of familiarity, but I don't know that anybody's specifically studying the effect of cannabis specifically, which cannabis withdrawal specifically on the quality of dreams. All right. Oh gosh. Let me see if I can remember your name. Wait. You are Chris. Is that right? Chris from San Francisco?
Absolutely correct.
All right. Awesome. Great to hear from you again. What's on your mind?
Well, I'm starting school tomorrow. I'm going back to a community college. The first time I've been to school since 1977.
All right. Congrats.
Is my brain up to the challenge?
That's really interesting. Earlier today I was thinking, what a life it would be to be able to just, once you're done working, just go back to school and study things that are interesting to you. How wonderful that would be. So it is uncontroversial to acknowledge the fact that adult brains are rather different from the brains of people who are typically, of the age that people undergo education. Oh, it's awesome to see you. Sarah, geez. As an aside, total tangent, Sarah Mojarad, and I hope I'm not mispronouncing your name, does really fabulous analyses of science communication and medical communication on Twitter. So go find her. I think that's her handle. Very illuminating. Okay, back to brains, back to adult education. So yeah, the brains of young children, adolescents, and really in our early 20s, it's pretty different from, when you're my age or older. I'm 32 now. And the primary distinctions are the following. First, the brain is far less neuroplastic. It's a less dynamic environment. There are fewer synaptic connections. There's lower excitatory signaling. And so as a result, it is different. However, and this in part explains why it is that, children can pick up languages without even trying. And it's extraordinarily difficult, at least for me to. But that old, cliche, you can't teach an old dog new tricks. Totally not true. People our age or older are absolutely still receptive to new information. Their brain still absolutely changes in response to new stimuli. It's just a little bit slower. And now I think a case could be made that the motivating factors that are at play in the brain of an adolescent are, also quite different, right? You're being bombarded with testosterone and changes in hormone levels, and, your libido is nuts and, no pun intended. And, and so there is a clarity, I think, that comes with maturation, and, you're not being threatened by all of these kind of novel motivations. And so perhaps, there's an argument to be made that your ability to focus in on a specific goal is perhaps superior, at least in some cases. But do you mind if I ask, Chris, what are you studying?
Well, I'm going to be studying voiceover work, public speaking, internet broadcasting, different ways to do electronic media with my voice. That's
awesome. Yeah, I should say, Chris, you have a great voice for that. So hopefully you'll be able to teach me some things when you're finished.
So I should not have any trepidation about being a 63-year-old community college freshman.
Not at all. I mean, I there's no good reason, at least. It is going to be a little bit different probably than you remember, but I suspect, I wish that I had waited a little bit before I started graduate school, and actually before I started college. Because I think there are some advantages that come with that changed biology, as things are less in flux. I would not be trepidatious.
All right, I'll keep you posted, and I'll invite you to my graduation in 2030.
I'll be there.
Okay, thanks.
All right, take it easy. Chris in San Francisco, always a pleasure to talk to him. Good luck. Yeah, everybody wishing you good luck. So you also have that on your side. Testosterone, indeed. How can I trust you when your memory is so bad you need 50 Post-it notes on your wall? It's a very, very fair point. I have no reason for them to be up there anymore. This was from actually preparation for my defense. But now they've taken on this sentimental value for me. So they didn't serve. If I didn't know the information, I was in trouble because there's just no way that I was going to be able to recite them during the exam after the public component of the defense. So when you're finishing up a PhD, you do three main things. The first is you write a dissertation. So that's the big book that explains how you've been wasting all your time since you started grad school. The second thing is at least in our neuroscience department at the University of Pennsylvania, you give a public talk to really whomever wants to come. People from outside of the university can come if they want. I don't know why they would inflict that upon themselves, but people from all over the campus certainly came to my public defense. And then you do the actual defense. Then, you sit in a room with, 4 or 5 or so senior scientists, and they grill you. And that's for me, I really wrote out certain concepts in a specific way that I thought would help me to communicate these concepts more clearly. I mean, clearly I could benefit from doing that right now, right? But just the phrasing in particular, delivering with clarity was what I was trying to do, so that I didn't get sort of mixed up in trying to express these concepts that are rather difficult or at least complex for me. And I could just get, finish, start and finish within, in a timely manner. But hey, fair enough. Listen, my memory is not great. If I don't take notes after I've read a scientific article, it's lost. It might as well not exist for me. Okay. Are Dr. Amen's SPECT scans approved by the medical establishment? No. So what our friend here, Psychic Trump, is referring to is a physician, I believe, named, I think, Daniel Amen. And I think he has sort of his own clinics, I think mostly throughout Florida, but I could be wrong about that. And but ultimately, his argument is that he uses this fairly simple compared to other neuroimaging platforms technique called SPECT scanning, which is it can be informative. But the problem with what he does, and his whole argument is that we can diagnose conditions like ADHD using neuroimaging, and theoretically he might be, in principle correct. But first of all, we don't know enough about the neurobiology of ADHD to confidently use anatomy, even functional anatomy like patterns of brain activity, to accurately distinguish, a patient population or folks with ADHD from folks who don't, in a way that is corroborated by psychiatrists, and neurologists, psychiatrists, I should say. And so, if there was nothing wrong with the way he is conducting this treatment, then he could have published this argument in a peer-reviewed journal. He has been published in journals, and that would have become the norm in medicine. I mean, there's few things standing in the way of using fMRI or even more effective neuroimaging techniques than SPECT scanning to diagnose ADHD. But it has not been convincing enough to people in medicine or in neuroscience to reach a level of consensus where it's justified. And I think that this sometimes happens. So the appeal, however, of somebody like him is that he has a very convincing, concise explanation for a way to improve your life, right? And he has a very specific group of people that he describes as inaccurate or, inaccurate or insufficiently aggressive or ambitious. And it's sort of like this very gratifying story. And, at the end of it is theoretically improving usually your child's quality of life. So, but again, the problem here is that SPECT scanning is not very precise. It's among the lower levels of, comprehensive imaging technologies. And even beyond that, even if he was using the most, a 9 Tesla fMRI, even if he's using some of the most accurate fMRIs is more, arguably more detailed, more granular in what it generates for you. Even if you're using that, neuroscience hasn't progressed to the point where we can, confidently identify very specific neural correlates of ADHD. So, I think it's a problem. Maybe we will get to the point where something like that is more common, but it is a problem. Thoughts on the pineal gland? It gets way too much press for such a small, unremarkable part of the brain. I actually talked a fair bit about the pineal gland a little while ago, about why it is that people care so much about the pineal gland, why people call it the third eye. It's an interesting evolutionary explanation, well, potential explanation, but why you shouldn't care so much about it. All right. Are you less susceptible to depression because of your knowledge? No. In fact, a neuroscientist who is far wiser, more intelligent, and certainly more accomplished than I, Robert Sapolsky, suffers from depression. He's brilliant. He's a brilliant writer and he's a brilliant scientist. And he therefore, and also a brilliant teacher. He's a teacher, I think, at Stanford. And as a result, some of the most clearly expressed explanations of depression are from him. And so, knowledge in and of itself is not an effective, prophylactic to depression. Understanding a thing doesn't necessarily help you to treat it. Okay, hello, which subject you are talking about? Whatever you want. Okay, do you know about psychopaths? What is it? Where Hitler, Stalin, psychos? Well, it's very, very difficult to diagnose something like psychopathy from a distance, right? Aberrant behavior is certainly one component potentially of psychopathy, and I would imagine psychologists have differing perspectives on this. But psychopathy is an interesting thing to read about. I guess maybe like half a year ago, I did a sort of review of what it is people talk about in the scientific community when it comes to psychopathy. And in the clinical literature, at least in some of the writing, it seems like there's not exactly a consensus on the distinctions between psychopathy and sociopathy. Probably the most common distinction I saw was that sociopathy is acquired, and psychopathy is like congenital, essentially, or you're born with it. That was not necessarily the most consistent distinction. Another distinction that I saw is like sociopathy is associated with violent aggression, violent transgressions, I guess, on others, whereas psychopathy is not necessarily, it's sort of a value neutral thing. It's just, it describes a person who has a lower level of an empathetic response to the experiences of others. I think it's perhaps a little perilous to try and understand or explain aberrant and grotesque behavior from people in history by just saying, oh, they're a psychopath. Because there are plenty of people who would be identified as a psychopath or, have psychopathy who are not violent at all. In fact, I recall having a conversation with somebody on this platform who was, diagnosed, which is pretty surprising. I don't really hear about this as commonly, but he said, he had a physician tell him he's a psychopath, and he was like, that's weird. Like, I've never had, any violent predispositions, and as a result, it's I think popularly misunderstood. But anyways, yeah, I think it's sort of a perilous strategy to basically like medicalize the grotesque events in history. There may very well be other explanations that need not arise from an absolutely an aberrant neuroanatomy. But it's a very interesting topic, and there's some interesting stats that like evidently it tends to people who might be recognized as psychopaths tend to aggregate at at like the C-suite in corporations, like the CEOs and so on. It's an interesting phenomenon potentially, but yeah. Anyways, yeah, it is an interesting topic. Depression is a demon oppressing you. Well, you're not the first person to compare depression to some sort of metaphysical challenge. But anyways, the girls are back from their walk, and so I guess I will call it a day there. So thanks very much for hanging out, everybody. My name's Ian McLaughlin. I have a podcast that I'm planning on updating in the not too distant future called Wired to be Weird on iTunes and Stitcher and Alexa. She's listening. and so on Google Play. And I have a YouTube channel. It's very, very nascent, but you can find it by doing like Ian Anthropoid Brain or something like that. You'll probably be able to find it. I talk about specific topics in like the first 15 or so minutes. Today, it was like how it is that the brains of an infant and of an adult influence one another in a sort of reciprocal back and forth way. It's a very, very interesting study. And almost just as interesting was how they conducted this study. They used this very interesting sort of evolution of fMRI. And I have a Patreon that I'm going to update very soon. And I know not everybody's in a position to be able to have the disposable income to contribute. But if you are, I would appreciate it. It's patreon.com/anthropoid. Otherwise, I hope to see many of you here, same time, same place, next week. See you guys.